we typed, we could assign a particular meaning to it, whether that was me typing ls or whether that was me pasting a piece of text onto the prompt. We knew exactly what each activity was, so it gave us something known to work from. And in constructing that, we also had connections that were not directly from campus to here. We had connections that went across the country and back in order to introduce some variability as far as the timing at longer round trip times. The third packet trace consisted of some, again, Leipzig data, but these were connections that we went through using the visualization tools that we developed, and we call them all, you could say they were almost known, because you could go through and the visualization tool is powerful enough that when you look at it, you can get even though it might not be detectable in some sort of a regression or something, your eyes will be able to tell you there's definitely a signature to these keystrokes, and your eyes could tell you that this is definitely a keystroke. So we went through and manually created some groundings in that sense. And finally, the fourth set of packet traces we used were collected from Purdue's statistics department. These were connections that went from the department to the outside. So from the department to outside of Purdue, and from outside of Purdue back in. And there were 110,000 of them. They were collected over a 24-hour period, and we used those for some of the testing that we've done to this point. So the first plots I'm going to show you here just were some things that were made in the very beginning to give us an idea of where to go. And this is a very high level plot, and what you have here is a cumulative bytes versus duration. And in this is a interactive connection with 37 keystrokes in there, you see. And what stands out mostly about this plot is that you have the two lines that seem to be very close to each other, and that indicating the number of bytes going in each direction. And down here in the third panel, you have these red dots corresponding to where our keystrokes are located in here. But what this is really saying is that when you have keystrokes, you have roughly the same amount of information going back and forth. So an interactive connection, you're going to expect to have the same amount of information going in each direction. And that was definitely a signature that we were able to pick up on using some of the higher level plotting tools. Whereas, and we were able to take this and use this to refine and build our next stage of plotting tools. And the series of plots I'm going to show you now are where we actually kind of got into the nitty-gritty of how do we see these keystrokes. And this is an example of a low-level plot, and these are specifically known activities. So this was actually me sitting in the statistics department, logging into one of our machines there, and you can see as we go through here exactly what happens in this connection. So to give you a little bit of the lay of the land here, the circles here, the red and the blue circles correspond to packet sizes. So this red packet would correspond to a client packet with 100 bytes of data, whereas this blue packet would correspond to blue circle would correspond to a server packet with 52 bytes of data. So red signifies client, blue signifies server. And as you look through here, it looks like kind of a mess for the beginning, and that's the SSH negotiation up to about packet 38 or so here. And once you get to packet 38, you start to see that client data, server data, client acknowledgement sequence that I mentioned that was a standard keystroke sequence. And you look at it and you say, all right, well that's kind of what we expected to see. That's nice. We see two of these are the same size, and then there's a packet containing no data, which is exactly what we'd expect. You go on and you see another one, and you see another one. And that's me typing ls and hitting return. Whereas you come down here, this packet corresponds to pasting some text into the at the prompt. And finally, I type ls again, and you see that these packet sizes are maintaining that standard form. And then finally, I type exit and close the connection. So that gives you an idea that we've got our packet sizes here that are coming out as we expect. But what's more important is that when you look immediately up from each one of these packets, here you see there's a yellow diamond that falls immediately above that client data packet. And that yellow diamond is plotted against the right-hand scale here, which is a log base 10 of interarrival time. So this log base 10 of interarrival time these interarrival times that we're using here, let me step back one moment and say the interarrival times are between consecutive data packets from the same source. So for instance, if you have a client data packet, then you're going to have, eventually you'll have another client data packet. That interarrival time, based on those two packets, you take the log base 10 of it, and that's what the yellow diamond corresponds to. The green diamond here would correspond to the interarrival time, the log base 10 interarrival times computed using only the server data packets. And so what the nice thing that we see here, though, when you look at this plot, is you see that as you look at this first keystroke here, you see the yellow diamond and the green diamond very near overlap and are almost at the exact same height. And you look at the next keystroke and you see the same thing. And you see the same thing. And as you go through here, looking at each one of these things, when you see a keystroke, you see a pair of the yellow and the green diamonds. And what that signifies is that we have a strong correspondence between our interarrival times based on the client data packets and their echoes from the server. So that was kind of a key finding here, and it is a signature that's used when these keystrokes get a little messier. As far as other difficulty that we see, depending upon your implementation here, you have keystroke packet sequences of varying forms. So for instance here, again you see some regularity in form here. There's a client data packet followed by a server data packet, server data, to client acknowledgements, and so on. As we move through here, you see again this is a 5-packet sequence: client, server, server data again, to client acknowledgements. And what this gives us here is we've got a 5-packet keystroke sequence instead of the standard 3-packet keystroke sequence. And the nice thing is, though, they're all initiated by a client data and they always have an echo to them. But especially telling here is, again, we have our diamonds lining up nicely. So you have those server, the client and server interarrival times line up very nicely. So that's, again, a key in identifying it. Even though the implementation in your keystroke packet sequence form has changed, the timing still remains the same. This is an example of mouse movement here, which comes out to have something that looks very similar in the fact that we've got a lot of packets of the same size. So we've got a lot of client data packets followed by server data packets. And we've got a lot of yellow and green overlapping diamonds. But these diamonds they're a little lower than the diamonds we've seen in the past. And that goes to the significance of what this gray band is here. This gray band that you see here corresponds to typing rates between 200 words per minute and 10 words per minute. So the bottom the bottom edge of this would have interarrival times that project to a typing rate of 200 words per minute, and the top would have typing rates that project to interarrival times that project to a typing rate of 10 words per minute. So when you see interarrival times falling in that band, it's a good sign that we're on to some keystrokes here. And these are just a little bit low, so it's a little too fast, and it's probably signifying that we're dealing with something that may be more an automated type communication or interaction here. Finally, this is an example from the Leipzig data, and it goes to show kind of how we can take what we've learned from some of these standard connections and extrapolate a little bit. So what you see here is what appears to be an SSH connection, and when you look at it, we start here and we see, say, a packet 38 there. You see kind of what begins to be the standard sequence as far as client data, server data, client acknowledgement, followed by here's a short sequence of client data, server data, followed by client data, server data, client acknowledgement. And so we've got a little variability in the form of the keystroke packet sequences, so clearly you can't use that. But the nice thing that we see here is, again, you have these diamonds lining up very nicely in these interarrival times. So the consecutive interarrival times turn out to be a very nice tool here, and when you couple them with the packet sizes. So this is a very strong indication that we'd be dealing with some sort of an SSH connection here. So to summarize, what we were able to learn from these visualization tools is there's some fundamental characteristics that are going to help us out to identify keystrokes. One, all these keystrokes are going to occur in groups. You aren't going to have someone just typing a K by itself is not going to do anything for you. So we're going to have keystrokes in groups. Second, every keystroke packet sequence has to have we know it has to have an echo in it. So that's the second